Sure. So this paper is mostly about predicting the paralinguistic side of the information, not only the content itself, like related to ASR, but like more focusing on more general aspect of speech. So when we kind of doing the prediction, our strategy is trying to predicting like a different metrics together from the different dimensions of the speech itself. So our strategy is more firstly starting from this token set, where we kind of gathering like many of the different act model from speech to recognizing, for example, the speaker gender, speaker age, emotion, and so on. We're together with some ground label from the existing data, so that could be kind of utilizing diverse information as much as possible. From that end, our focus is then becoming to giving a speech, we're predicting many different dimensions at the same time. So it's kind of formulating this kind of speech multi-metric estimation test. And to achieve that, we're actually utilizing this dynamic classifier chain strategy, which actually starting from this kind of metadata and value token as a following, so which are formulating as a pair. And this pair is actually kind of repeated for every matrix and going to a full sequence together. And during the prediction, actually giving this multiple example from gender, emotion, and modes, we are trying to predicting this kind of random shuffling during the training. So which kind of have the chance to, for every matrix, so depending on different matrix as a prior. And during the forcing scenario, it's become quite natural. And we're doing the decoding stage, where we come focusing on like utilizing different like value token confidence to decide which token to consider at the point. And it could be also combined with the beam search for sure. And there are quite a few fascinating points from this kind of combinations. Firstly, we can get very good performance in now, and we can get very good like a kind of interpretability over all the metrics together. We also have a sequence of metrics. Some metrics will be easy to predict at first, some will be hard to predict at following. And this kind of formulating into a framework that will be kind of analyzing how the matrix are visualizing with the dependency chain and so on. And there's quite a few notable findings here. Like for example, we can naturally control the sequence. We can manually control the order of the sequence itself, but we can also like doing a random like decoding directly from this component-oriented decoding. Whereas we can also like doing some ground truth label as a prior, so which can significantly improving the whole performance as a whole. And we do expect many of the future works, which we thought will be very fascinating. For example, by extending this into the natural language, this is kind of a structured form, but we actually want to extend it to the natural language itself. Whereas also trying to leveraging more information from general music and audio, not only speech, to realizing the whole audio understanding scope, and also to adding the temporal information, because that's very important aspect of speech. So like to formulating into this sequence. So like that's pretty much something that I want to share. So thank you so much.